Welcome back. This is the second video for this unit covering quadratic functions. In the first video, or in your first lesson, you should have learned some vocabulary for different things for this unit. You should have learned what a quadratic function is, and then gone into some characteristics of quadratic functions when we draw them on graphs. Quick refresher for you, a quadratic function is something with a square in it, so an x squared or a y squared, and when you graph them, you get parabolas. In this lesson, we're going to go a little bit more into the characteristics of those quadratic functions in specific forms. So, in particular, we're going to be looking at one form of quadratic functions a little bit more so. So, our goal here is to look at the vertex form of quadratic functions. So when we're dealing with our quadratics, there are two sort of general forms that they're going to come up in more often. We can use them both for different things, but they have pros and cons for specific situations. So the first, which we're not going to focus on in this video, is called standard form. And it's sort of like the clean-looking polynomial version. So we can think of that as something along the lines of f of x equals ax squared plus bx plus c, where a and b and c will all be numbers. That'll mean different things. So, for example, you might have something like y equals 2x squared minus 4x plus 5. And you can do stuff with that. You can graph it. You can use it to solve equations. Very useful. The other form, and the one that this video is more concerned with, is called vertex form. Now, if we look at vertex form, it's not going to look as pretty. So it's f of x equals a, and then we've got some brackets in there. So it's x minus p inside of brackets. And then that is squared, and then plus q at the end, where again, a, p, and q are going to be numbers. So if you want a more generic one, or more, you might have something like y equals 2 times x minus 1 squared plus 3. So you look at it, and it doesn't look as nice as standard form to look at, but it does have its uses. Specifically, it's really helpful when we're graphing. And the reason for that is those three letters, A, P, and Q, they mean something. So A, P, and Q are what we call parameters. And when we say parameters, they're numbers that we can change that will affect the graph in different ways. So if that A value is a 2 versus if the A value is a 3, or a 5, my graph is going to be different. It might be in a different place. It might have a different shape. Maybe it'll be facing in a different direction. Changing the numbers changes things on the graph. And so our goal in this video, or in this part of the chapter, is to find out what exactly A, P, and Q do. And so this one is going to work a little differently than many lessons. I'll invite you to pause here and check to see if you can find a file in the description of this video or that you got in class that has a vertex form activity. And you're going to take that, you're going to work through that activity on a website called desmos.com. It's a graphing calculator. And through that activity, you're going to figure out on your own what A, P, and Q do. I'm going to have a separate video that works through parts of that activity. But in this video, I'm just going to skip straight to the end and assume you've done it. So go ahead and pause right now, do the activity, come back once you're done, and see where you ended up. Okay, so after investigating on Desmos, looking at our three parameters, A does two things. So first off, it decides whether our graph opens upwards or downwards, or if you think back to our vocabulary, it affects our direction of opening. And that is dependent on whether our a value is positive or negative. So a positive a value will open upwards, and a negative a value will open downwards. A also does something else, though. It affects the steepness of our graph. You can think of it kind of like slope on our slope-intercept form from grade 10, the y equals mx plus b. It's not quite slope because it's not a straight line, but it's the same basic concept. So the larger the slope, or larger the a value rather, the steeper your line goes up. If you have a really low a value, something like 0.25 or 0.1, you're going to have a very shallow parabola. Some people also think of it in terms of the width, and that's also a totally reasonable way to think about it. So the bigger your a value, the skinnier your parabola gets. If you have a really small a value, you get a very wide or shallow. Okay, so that's A. P also does, well, it really does one thing, but we can think of it in a few different ways. So the technical way of thinking about P, so if you looked at the activity, as you change it to P, the graph would have moved left or right. So we can think of P as translating, that's your technical term, translates your graph right or left. And this one does get confusing. I'll have covered that in the other video, but it translates to the right when P is positive. But the way our general vertex form looks, I'm going to scroll back up here. This right here is a positive 1 because our P value right there is x minus P. So that's x minus positive 1, not x minus negative 1. So in this case, P is positive, and this graph would be moving right. But people do tend to get mixed up about that a lot. So it's something you're really going to have to look out for when you're dealing with parabolas in vertex form. So I'll write a note on that. Right is positive. You can also think of P as telling you a very specific and very helpful piece of information, which is where your vertex is. So it is the x-coordinate of the vertex. And then Q is basically the same idea, except instead of being horizontal, it's vertical. So Q translates the graph vertically. That's up and down. And same idea, positive is up. But Q is less confusing because it's plus Q, so people understand what they're doing. And it also tells you where your vertex is, but it tells you the y-coordinate. And those two bits of information for the P and Q value, the x-coordinate and y-coordinate of the vertex, are why this is called vertex form, because it makes it really easy to figure out where your vertex is. And the vertex makes graphing really easy. So that's our last thing here. Our vertex is at P, comma, Q. So if we scroll back up one more time and we look at that other function that I gave you as an example, in this case, our P value is 1, our Q value is 3, and so our vertex here is at 1, 3. And that's all we've got for this video. So if you haven't already gone and taken a look at the activity, please do now. Otherwise, you can move on to the next one and see how to graph things in vertex form.